morning. I think it is audible. Total number present is 7 now. Now we'll start immediately. You see page number 60, example 3 first. Page 60, example 3. Construct a 3 by 2 matrix. The elements are given by A or row number, J. Okay. First element A11. First element A11. You see, you formalize 1 by 2 modulus 1 minus 3 into 1. So the result is coming 1. Similarly, A12. You see the calculation. A21, A22, A31, A32. All 6 elements you have to calculate first, then write in the row and column proper way. Here, the required matrix is, you see, there are 3 rows. First row, I mean row 1, 1, 5 by 2, row 2, 1 by 2, 2, and row 3, 0, 3 by 2. This is your example 3. Once again, good morning to all. Good morning to all. Whether you follow example 3 or not, you see and say whether you have followed or not. Example 3 completed or not, you see. After completing example 3, you refer example 2. Yesterday, I have told till then. You see again. Example 2. Tell me, today audible or not? Today audible or not audible? Clearly tell me. Shelly, Indira, Devi Prasad, Sukhanshu, Swadhin, Varsha, Saijyoti, Om Prakash, Aid, Kaustuv, Supradeep, all are present here. Now the number became 12. Okay, I think in evening it is not possible to take class. So we have decided tomorrow onwards there will be only 4 classes per day. That I will give a timetable. As for the timetable, you will see only 4 periods, not more than that. Fixed time, and during that time the concerned teacher will teach. And the timing will be from 8 to 9, 9 to 10. There will be a gap of half an hour. Then 10:30 to 11:30, 11:30 to 12:30. Not more than that. 2 hours, then half an hour gap, again 2 hours. Or I will try to reduce the time from 1 hour period to 45 maybe. I will reduce, but I will not increase. 4 periods per day. I will give the timetable today. Now I am consulting principal sir. Sir will give you the information also. Now, example 2, once again you see example 2. If a matrix has 8 elements, what are the possible orders it can have? A matrix with 8 elements given. What are the possible number of matrices? Write down 8 as a product of 2 numbers. Product of 2 positive integers. 8 can be written as 1 into 8, 2 into 4, 4 into 2, then 8 into 1. These are the possible products. 1 into 8, 2 into 4, 4 into 2, 8 into 1. These are the 4 possible cases. So we can form exactly 4 matrices. First one, 1 into 8 means 1 row, 8 columns. 2 into 4 means 2 rows, 4 columns. 4 into 2 means 4 rows and 2 columns. 8 into 1 means 8 rows, 1 column. Next, you do one problem now. You do one problem. If a matrix has 12 elements, you write, if a matrix has 12 elements, what are the possible orders it can have? Now you solve. Now you solve the problem. If a matrix has 12 elements, what are the possible orders it can have? Just to calculate and tell me only answer. How many such matrices possible? Number of element is 12. Okay, Saijuti, I will discuss example 3. I will do one similar problem. You do now. If 12 elements are given to you with a matrix, what are the possible orders? 12 elements, possible orders. Yes, first of already given that answer. Saijuti, Mohammad Aid, you all are correct. Swadin, Barsa, yes. Prayas, then Devi Prasad, Samikya. Okay, you all are correct. Indira, correct. Answer is coming 6 possible. 6 possible matrices or 6 possible orders. Your orders are like this: 1 row, 12 column, 1 into 12, 2 into 6 means 2 row, 6 column, then 3 row, 4 columns, then 4 row, 3 columns, 6 row, 2 columns, then 12 row, 1 column. In this way, you are having 6 possible answers or 6 orders. Yes, Om Prakash, Surupa, I'm getting answer from you all. You all have given the correct answer, that is 6. Now, proceed to types of matrices, page 61. Page 61, types of matrices. First, column matrix. Column matrix means a matrix is said to be a column matrix if it has only one column, whatever may be the number of rows, but it has exactly one column. All the elements are written along one column, whatever may be the number of rows. You see, one example is given. In this example, A is a matrix. In that matrix A, there are 4 rows, 4 rows, but one column. Its order is 4 into 1. 4 rows, one column. You cannot change the order and order. First is row always, and second one is always column. So always row first, then column. A column matrix is written in the form of M into 1. M indicates different rows but one column. Then come to second one, row matrix. Similarly, a row matrix is said to be a row matrix if it has only one row, but many columns. One row, many columns. Here, example given matrix B. In matrix B, only one row. You see one row, but the number of column is 4. 4 columns, one row. So the order is 1 into 4. One row, 4 columns. So in general, we are writing order of a row matrix is 1 into n. 1 into chess. Square matrix is a matrix in which rows and columns are equal. As per the definition of the book, a matrix in which the number of rows are equal to the number of columns is said to be a square matrix. A matrix is said to be a square matrix if a number of rows is equal to number of columns. In this case, m into n, if order is m into n, then m must be equal to n. Number of row if equal to number of column, then the matrix is a square matrix. See that example is given. It is a square matrix of order 3. Square matrix of order 3 means number of row here 3, number of column is 3. 3 by 3. In general, we are writing a square matrix as Aij. A small aij indicates the element. Small aij, the element present in ith row and jth column, and the order is written as m into m, or you can also write m into n. A equal to square bracket aij m into n, m into m, or n into n. Both are set. These are the three definitions: half page, column matrix, row matrix, and square matrix. Then next, you see what is the diagonal. Only A11, A22, A33, these are called diagonal elements. A square matrix of order n, then its elements, that entries A11, A22, A33, A44, A55, and so on up to ANN are called diagonal or diagonal elements. So elements, in the given example, you see the blue background. Last paragraph you see matrix is 1 minus 3 1 2 4 minus 1 3 5 6. It is a square matrix of order 3. Diagonal elements are 1 4 6. Only you take elements 1 1 a 2 2 a 3 3. These are the diagonal elements. Now next page, proceed to page 62. Page 62 has to see diagonal matrix. See now, diagonal matrix. A square matrix B, written as Bij here M into M, is said to be a diagonal matrix if all its non-diagonal elements are 0. That is a matrix B. Bij M into M is a diagonal matrix. Bij, when I is not equal to J, it's 0. Non-diagonal elements are zeros. If all the elements present in a non-diagonal place are zeros, then that is a diagonal matrix. Now question arises, whatever the diagonal elements, all diagonal elements are non-zero. Not all. At least one non-zero must be there. Some may be zero, no problem. Some diagonal element may be zero, but it is not mentioned clearly in your book. Only it is written non-diagonal elements are zero. Then proceed to scalar matrix. Scalar matrix. In scalar matrix, diagonal elements are same, and all other elements are zeros. A square matrix, if its diagonal elements are equal and non-diagonal elements are zeros. Or simply we are saying a diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. You see here A, example A written with a symbol 3 bracket square bracket 3 square bracket for matrices. Square matrix, square bracket is required for matrices. Then B, square matrix is for matrix symbol. Here minus 1 along the diagonal. So these are diagonal elements, non-diagonal elements are zeros. C, C is a square matrix of order 3. C is a square matrix of order 3. Its diagonal elements are equal, all are equal to root 3, and non-diagonal elements are zeros. So, scalar matrix of order 1, 2, 3, it is written. Scalar matrices means Diagonal elements are same, non-diagonal elements are zeros. If all elements are zeros, that is a zero matrix. I will come to that. That is in the seventh bit. Then proceed to sixth, identity matrix. Identity matrix is a square matrix whose diagonal elements are 1, non-diagonal elements are zeros. You see, a an identity matrix of order 1, it's only one. Diagonal matrix you see when diagonal elements are 1 each and non-diagonal elements are zeros. You see the example given order 1, order 2, order 3. In order 3, that diagonal elements are 1, 1, 1, non-diagonal elements are zeros. These are examples of identity matrices. Okay, then proceed to the next page. Next page is page 63, seventh one, V double I written zero matrix. A matrix is said to be zero matrix or a null matrix. The name for zero matrix is null matrix. Null matrix is also same as zero matrix if all its elements are zero. That zero matrix not necessary to be a square matrix. It may be any form, but that must be in rectangular form. Rectangular form. If all elements are zero, then the matrix is called a zero matrix. Here different examples are given. For zero matrix, we are using the symbol O. Zero matrix is represented by symbol O. Identity matrix is taken by capital I. Capital I is given as the name of an identity matrix, and capital letter O is used for zero matrix. Okay. Once again, you see all the seven matrices. Then I'll proceed to next. You take 1 minute time and just see the names only. When you see the names, automatically definitions will come. 1 minute to take just to revise. First one, first one again. That is column matrix. Second one row matrix. Third one square matrix. Then diagonal matrix, scalar matrix, identity matrix, and zero matrix. After reopening, I will collect these definitions from you. If you are clear in your definition, then it is easy to solve the problems. Now, equality of matrices. At what condition two matrices are equal? Suppose A is a matrix, B is another matrix. These two matrices are equal. First condition, if they have same order. Order must be same. Condition for equality of two matrices, two or more matrices. First of all, they must have same order. Then second condition, each element of A is equal to corresponding element of B. If two matrices are equal, then the corresponding elements are also equal. That is your condition. Two conditions, same order and corresponding elements are equal. Now, this Y, Z, A, B, C. Example 4. Equate the corresponding elements. Equate the corresponding elements. Just like x plus 3, it is equal to 0. So x is minus 3. Z plus 4 equal to 6. Z plus 4 equal to 6 means Z equal to 6 minus 4. You will get Z equal to 2. In that way, you calculate all the 6 values A, B, C, X, Y, and Z. Work out now example 4. Don't see. After doing example 4, do example 5 also. Don't open the next page. Work out quickly example 4 and example 5 now. Quick. Example 4 and example 5. Very simple. Equate the corresponding elements, then solve the equations and find the values. Example 4 and example 5. And inform me. Completed example 4, completed example 5 in that way. Okay, right. Very good. You have completed example 4. You may calculate roughly, but you work out. You calculate, not required to write in the systematic way. But you must calculate what are the values A, B, C, X, Y, and Z. For example, 4, and for example 5, you have to calculate A, B, C, and D. Linear equation may occur. Solving the linear equation also you can get. Okay, proceed to calculate. Today number present is 16. Out of 32 students, now more than 50% here 16 or Peter sitting with me. So total is 17 students. 17 students are in the class. If I'm audible and you are having book, then no problem to solve. Yesterday, I have already given the PDF file of chapter 3. If required, only exercises are required, or you can see your mobile or laptop and work out the problems. Both have completed. Okay, I completed. Where also completed. Shelly completed. Sailuki also completed both the problems. Okay, now you proceed to next page and check your answer. You all check your solution. Solution of example 5 is given in page 64. A1, B2, C3 and D4. 1, 2, 3, 4. Now proceed to exercise 3.1. I have told you yesterday. Work out and see up to exercise 3.1. In 3.1, now you do question number 2, 3 and 4 heartbeat, 5 heartbeat and 7. Go down again. I am writing here.